Good morning, class. This is Sir Emilio T. Tyre Jr. and welcome to the ninth day of our mathematics class. Today's learning objective is to find the sum of the terms of an arithmetic sequence given the first term and the last terms. Shoot for the stars. Jean, a grade 10 student who dreams to become an astronaut and loves to watch the sky every night, observed that in 2 weeks of his watch, small pieces of rocks, famously known as shooting stars, hit the Earth's atmosphere from space. Every night, the number of shooting stars he observed are increasing by 6. If there are 7 shooting stars at the first night and there are 85 shooting stars on 14th night, how many shooting stars entered the Earth's atmosphere in 2 weeks of Jean's observation? So to answer this problem, let's organize our data by putting it on a table. So the number of night, we have here number of night on our first row and number of shooting stars on our second row. So our first night has 7 shooting stars while our 14th night have 85. So in second night, how many, if it is increasing by 6, the numbers of shooting stars, how many shooting stars are there on second night? Very good, 13. How about on the third night? Very good, 19. How about on 13th night if there are 85 shooting stars on 14th night? Very good, 79. And at the 12th night, we have 73 shooting stars. Now, let's pair and add our datas. First, let's pair the first and the last terms, which are 85 and 7, or 7 and 85. The second pair we have 13, and let's go to the second to the last term, which is 79. Third term we have 19, and its pair is 73, the third to the last terms. So if we are to pair all the datas that we will have a total of 7 pairs on 14 nights. So let's add each pair that we have here. So 85, or 7 plus 85 is 92, and 13 plus 79 is also 92. 19 plus 73 is also 92. So if we have 7 pairs, then how many 92s do we have? Very good. We have 7 pairs of 92s, or 7 92s. 7 92. Let me delete this. From 7, by having 7 pairs, we have 792, and 7 times 92 is what? Very good. 600. We have a total of 644. So therefore, there are 644 shooting stars. On on 2 weeks of genes observation. Now, when we add terms to our arithmetic sequence, we come up with arithmetic series. So, arithmetic sequence is the indicated sum of the terms of an arithmetic sequence. The sum of the first n terms of a sequence, called the partial sum, is denoted by S sub n. So, when we saw S sub n, it represents the partial sum of the first n terms. So, if we are looking for the first 30 terms, then its symbol is S sub 30. So the formula is this one. S sub n is equal to n over 2 times quantity a sub 1 plus a sub n. So a sub 1 is the first term, a sub n is the last term, n is the number of terms, and S sub n is the sum or the partial sum of the n terms. And this formula is only applicable if the last term or a sub n is even. So from our first problem, we have the first term is, our a sub 1 is, very good, 7. Our a sub n, which is the last term, which is also equal to a sub 14, is equal to, very good, 85. So our n will be equal to 14. And by using our formula, let's check if it matches our answer a while ago. So S sub 14, this should be already 14. S sub 14 is equal to n, which is 14 over 2 times quantity first term, which is 7 plus 85. So let's divide first 14 by 2. We will have 7, and 7 plus 85 is 92. And we all know that when we multiply 7 by 92, the sum of the first 14 terms of the sequence that we have is 644. So it matches our answer. Next, let's have more example. A stack of soap boxes has 12 boxes in the bottom row, 11 boxes on the second row, and 10 in the next row, and so on. How many boxes are there in the stack? So unlike the problem that we have a while ago, here we don't know the last term, but we can identify it. How? By observing our sequence. So our sequence will go like this: 12, 11, 10, and so on. So if it is decreasing by 1, as we can observe here, then the last term will be 1. The last row of our boxes will have 1 box only. So, and how many terms do you think is this sequence have? Okay, so this sequence have 12 terms. So therefore, our a sub n is equal to a sub 12, which is equal to our a sub 12, or our 12th term is 1. So therefore, n is equal to what? 1. Very good. And our first term, a sub 1, is equal to, very good, 12. So by using the formula S sub n is equal to n over 2 times quantity a sub 1 plus a sub n. We will have S sub n. We are looking for the sum of the 12 rows of boxes. Our n is 12, so we will write 12 over 2. Our first term is 12 and our last term is 1. So by dividing 12 over 2, we will get 6 and 6, and we will have 6 times 13 because 12 plus 1 is 13. And what is 6 plus times 13? And any answer, or what's your answer when multiply 6 by 13? Very good. The answer is 78 boxes. So there will be a total of 78 boxes for this sequence of um, boxes. So on our last example, what is the sum of the first natural numbers? So when we say first natural numbers, it starts with 1. So therefore, our a sub 1 is 1. It doesn't start with 0. So next, then if we are looking for the first 100 terms, then our last term for this sequence, or a sub 100, is 100. So what do you think is the n, value of n? Very good, 100, because we are looking for the sum of first 100 natural number. So the sequence will look like this. And when you put it in an arithmetic series form, it will look like this: 1 plus 2 plus 3 plus so on plus 100. So using the formula that we had, we will get S sub n, or the formula is S sub n over S sub n is equal to n over 2 times 1, or a sub 1 plus the last term, which is a sub n. And we are looking for the sum of the first 100, so we will write S sub 100 equal to n, which is 100 over 2 times the first term, which is 1 plus 100. And 100 divided by 2 is 50 plus, or times, multiply by 100 plus 1 is 101. So 101 times 50, the sum of the first 100 terms is equal to 5,050. So again, I just want to emphasize that this is our arithmetic sequence, and this is an arithmetic series. So as you can see, they have their differences. Arithmetic sequence is partitioned by comma, while the series has plus sign in between terms. I hope you learned something today, and that would be all for today. Goodbye, class.